Listen up and see if you make it, if he's right.
Chlorine trifluoride.
He says chlorine trifluoride. Is he right?
Yeah.
Chlorine trifluoride. Very good. Ryan, next one.
Vanadium 5 fluoride.
Vanadium 5 fluoride. Jack, you listening?
I
Good.
respectively disagree.
What did you, for number B, for letter B?
Vanadium 3 fluoride.
I respectfully disagree with you.
I agree with him.
Jen,
Oh, I
I
thought it said
disrespectfully,
three.
I disrespectfully
I'm sorry, I thought it
disagree
said
with you.
3.
Okay, that's fine. You got the technique down. Next one, Jen. CuCl.
Copper 1 chloride.
Nice. Next one, Allie.
Manganese.
No.
Manganese.
Manganese. Or oxide.
Excellent. And Ben.
Magnesium oxide.
Good. And the last one, Connor. Don't say water.
Water.
Don't say water.
Hold on.
But see, you're saying water. He's saying water.
Oh, okay.
Water.
It's water.
Shut
Dihydrogen.
Oh.
Dihydrogen Jamaican rule. Monoxide.
no.
Dihydrogen monoxide.
I know.
So you guys all got it? It looks like you're pretty good, yeah?
So it's
Dihydrogen monoxide. Dihydrogen monoxide. Are you ready for type 4? Okay, I'm not gonna do the whole thing. I'm just gonna
Is she
introduce
gonna
it.
teach us this?
Yes, I'm just gonna introduce it tonight. I'm not gonna do the whole thing. It's previews are coming attractions. So stay with me, guys. Everybody ready? Ladies? On your pens, I gave you some of the most common polyatomic ions. Polyatomic ions. So before you open your pens, everybody look up here. Right here? Just take a look at the way I organized it, because it's really easy if you organize it this way like I have. These guys, first of all, are called polyatomic ions. So we have this guy, PO4 minus 3. It's got a -3 charge. This is a clique of nonmetals, all of which together have a charge. But it's like a clique. It's not like a single negative ion. It's like a bunch of negative ions that got together, hooked up with each other, like mean girls, and then walk around dissing everybody because they're negative. So it turns out that if you have a P followed or hooked up with 4 O's, walking around, they're a -3.
What?
They're a -3 complex. This is called a polyatomic ion because there's many atoms in the ion, and they're always nonmetals. So it's P with 4 O's. Just accept. Well, that's okay. I can't explain why it happens because this book is so stupid. It doesn't explain why these things work this way until chapter 11.
Every day she talks about how we're shouldn't know the valence shell. She's like, but I know you know them.
Well, why doesn't she just teach you chapter 11 now instead of waiting till next semester? Somebody should tell her, look, you should teach chapter 11 now and not wait till second semester when it's no good.
And then you wonder what she'll do? She'll be like, did Tom tell you that?
Okay, fine. We can say yes because that's the way you should do it. No, do this. The teachers at Campo do it. Tell her, no, my friend at Campo said his teacher skipped to chapter 11.
Oh, okay.
And then you're clear.
Are the Campo Chem teachers better?
Yeah, absolutely. First of all, they're intelligent. They skip, not all of them. But one of them in particular, Miss Eaton, is really good. She skipped to chapter 11 because it makes much more sense to do chapter 11 now than in second semester when it doesn't do any good because now is when you wonder why these things are like this. Yes.
So, is like H2O a polyatomic ion?
No, because it's a compound. Guys, an ion has to have what? Everybody look. This is a crucial point. Guys, an ion has to have a charge. Jack, stay with me. This is a very important point. An ion has to have a charge. So if you have H2O, it's just a compound.
Yeah.
But if you had H3O plus, now it would be a what? Polyatomic ion. But you don't have to know this till much later. It's okay. But these guys you have to know now. So here's what I did. I took the most common polyatomic ions. You shouldn't have to memorize them. When I went to school, it was all open book back in the day. It's stupid to memorize this kind of stuff. So I put it on the pen, and I organized it like this. Notice, 3 columns. The first column is, there's only one, PO4, phosphate. And there's also one with one fewer oxygen. I put the charge up here, phosphate and phosphite. So look at the naming. This guy is phosphate, and this guy is phosphite. What's the difference? 4 O's and 1 O.
That's 3.
Well, it's right. 4 O's and 3 O's. Good point. But this one has one less O than this guy does.
Yeah.
So the polyatomic ion that has more O's gets the 8. I can't believe I ate the whole thing. It had so many oxygen. And the one that has fewer oxygen gets the ite. And for the street girls, we just say ite. Okay? So this is going to be phosphate, and this is going to be phosphite. Ite? Ite. Now, same thing goes on over here, but these are -2. This is a -3. How come? For now, just because. Over here, you got sulfate. And then over here, you've got and they both have a -2 charge. I didn't put the -2 on the pen because it's too small to fit in for the printing company. So I just put them up in columns. Everybody see how it works?
Yeah.
Everybody in the -3 column, there's only 2, and they sound the same, phosphate, phosphite. Then we got sulfate and sulfite, and 2 more, carbonate and carbonite. Carbonate and carbonite. Why? The 8 always has 1 more oxygen than the ite form.
Can you spell that carbon dioxide?
No, because it's got a -2. That's an excellent.
Oh.
That's such a good question, though, Jen. That is such a good question.
Good job.
Look, she wants to say, well, this is carbon dioxide, isn't it? But when I do this to it, now it's transformed. Now it's carbonite. So that's the difference. That's an important difference to make. This is an ion. This is a compound, and they're totally distinct and different species. So other questions so far? And then there's a couple over here, nitrate and nitrite. And then there's a couple more down here. But here's how you organize in your head or on the pen. There's only a couple, 2 of them, -3, and they're both the same sound. There's only 2 of them, -2, and the rest of them are -1. Now she may throw in a few more if she wants to be mean, but those are the most important ones. And it's easy on your pen. If you just pull it out periodically, you'll have them memorized pretty soon, just by taking a look at them and memorizing them by column. Your book does it like this on page 109. It's like the stupidest way to present polyatomic ions. They just throw them together like pigs in a stall, and you have no idea which one goes where or why. So exactly, it's an old farm thing. So that's what I wanted to talk about. Last thing, how do they work? So watch. I'm just going to hook up a couple of them. These are like Lego parts. We're going to take a polyatomic and a metal, 2 Lego parts, and put them together like this. Let's take PO4. What's the charge on PO4? It's a -3. And let's take sodium, Na.
I have a question. Why is it a minus? Oh, just because.
Just because, yeah. You have to, that's chapter 11, and I can't explain it right now, so it's just because. But do we know the charge on sodium?
JB.
Everybody look.
+1.
+1. Now, what do we do? These are ionic compounds, metals plus polys, type 4. Metals plus polys, type 4. Your book calls them, to be absurd, it calls them more complex compounds. Whoa, that really is enlightening. Okay, more complex compounds. I'm so glad they type. Okay, MCC, or I call them type 4 because it's so stupid to type them anyway. So it's a poly plus a metal. Poly plus a metal. Now, what happens? We flip, flop, and drop. So the 3 goes over here, the 1 disappears, and you end up with Na3, PO4. Previously coming attractions. Don't worry. Don't worry. I'll come over it. I'll go over it again next week. Last one. Let's take SO4. Let's take SO4 with lithium. SO4 is -2. How come? Just because. Lithium is +1. So again, we flip, flop, and we get Li2SO4. Now these are not binary because they have 1, 2, 3 types of elements represented.
What's the
Three.
flip and
Oh.
what's the flop?
We're just doing the same thing we do with the
LISO.
ionic compounds. We flip, flop, and drop. If we have a charge, I'll do it one more time. Let's take
Sorry.
magnesium, and let's take nitrate. Okay, MgNO3. -1, +2. When we have a metal and a non-metal, we have to flip, flop, and drop to make the compound.
Yeah.
So the 1 goes over here, and the 2 goes over here. But when you flop across a poly, you got to parenthesize the poly. So this is how we make these molecules with polyatomic ions.
So is it NO6?
No, it's just it's just magnesium nitrate.
Okay.
You don't remember with the regular metals? You just say the name,
But you don't
magnesium nitrate.
distribute the 2 into it?
No.
Okay.
You put parentheses. Otherwise, it would look like this. It would look like MgNO3. It would look like MgNO32.
But could it be like MgNO2O6?
Yeah, that's what I was
No,
thinking.
you don't, because the poly's a click. It's like this. It's N with 3 O's. It doesn't walk around with like this. That would be what you're thinking of, N2O6.
Yeah.
Oh,
It doesn't look like that. It looks like this. There's 2 separate ones floating around. So the polys are like little clicks that always stay together. So you wouldn't have this kind of thing. You'd have 2 of these. Another guy over here, here, and here, and then both be floating around. Everybody good?
Yep.
That's it for today. I'll go in more detail next week on this.